Good day, welcome to this lecture series on lipids. So how do we define lipids, or what are lipids? So lipids are a class of biological molecules defined by their low solubility in water and high solubility in non-polar solvents. So when we talk about non-polar solvents, we talk about solvents that are immiscible with water. So example of these non-polar solvents are N-hexane, butane, dichloromethane. Now the lipids found in the biological system are either hydrophobic in nature, that's water heating, let me put it that way, containing only non-polar groups, or amphipathic, possessing both polar and non-polar properties. Now, the hydrophobic nature of lipids molecules allows membrane to act as effective barriers to more polar molecules. What means that the membrane bilayer, which is made up of phospholipids, are actually less permeable, or they are actually less permeable to more polar molecules. So there is need to have transporters for those molecules into the cell. That's why we have transporters in cell membranes. Now, what are the functions of lipids? Lipids are molecules of choice when it comes to metabolic energy storage due to the high reduced carbon form compared to carbohydrates. Carbohydrates are usually more oxidized, having more hydroxy group than lipids. They serve as intermediates for hormone synthesis. Example of hormone, talk about the estradiol, which is the principal female hormone, the testosterone, the principal male hormone. So cholesterol is a precursor for the synthesis of these hormones. And they can also function as bile acids, which help in the emulsification of fat foods or fatty foods in the stomach, or less in the small intestine, usually in the small intestine. They constitute membrane bilayer, which I've actually talked about earlier. They can act as water repellents, usually in waxes, what you see in the candle wax, and other wax that are made up of maybe some of the insects or birds that will not allow water to soak them. So that is, let me put it this way. Most of these insects, where you have water on, or maybe plants or birds, the feather of birds, find out that they usually repel water, so they don't allow the water to stay. So those molecules that don't allow the water to stay, or to soak this insect or the birds, we usually refer to those molecules as waxes. Now the lipids can also function as transporters, usually transporting various food to various systems of the various systems or tissues or organs in the system. So we have the function as lipoproteins, made up of lipids and proteins. Example is the low density lipoprotein, which is known as the bad cholesterol. High density lipoprotein, which is also known as the good cholesterol. They can also function as coenzyme. Example is the vitamin K in thrombin. Thrombin is responsible, or is the principal protein in blood clotting. So we can also talk about lipids function as neurotransmitters, usually when we talk about the gangliosides and the rest. So we'll get to that point. So in this lecture series, we'll be looking at the structure and chemistry of fatty acids, structure and chemistry of triacylglycerols, structure and chemistry of glycerophospholipids, sphingolipid, waxes, terpenes, and sterols. So we're going to be looking at these individual lectures in our next videos. So now let's look at the structure and chemistry of fatty acids. Fatty acids are composed of a long hydrophobic hydrocarbon chain, which we usually refer to as the tail, and the terminal carboxyl group, which is usually referred to as the head. In the next slide, I'm going to draw a fatty acid so that you look at the hydrocarbon chain and the terminal carboxylic group. And the carboxyl group is normally ionized under physiological solution, which means in biological system they are usually ionized, which means they've lost the hydrogen atom that makes it an acid. So fatty acids are either saturated, or carbon-carbon bonds are in single bonds, or unsaturated with one or more double bonds in the hydrocarbon chain. If the fatty acid has a single double bond, it is said to be monounsaturated, and we have only one single bond at the length of the carbon chain. then to the hydrocarbon chain. And if it has more than one double bond, we refer to it as a polyunsaturated fatty acids. Now, the free rotation around each of the carbon-carbon bond makes saturated fatty acid extremely flexible molecules. So most of the fatty acids found in nature are even numbered. Number of carbon atoms, usually from 14 to 24. Certain marine organisms, however, contain substantial amounts of fatty acids with odd number of carbon atoms. Some fatty acids are not synthesized by mammals, and yet they are necessary for normal growth and life processes. These essential fatty acids include the linoleic acid and the alpha-linolenic acid. These are the two essential fatty acids because the human system cannot synthesize them. So we need to eat them we need to get them from our dietary source. Arachidonic acid, which is actually one of a fatty acid that cannot be synthesized by plants, but can be synthesized can be synthesized by mammals only from linoleic acid. That's why linoleic acid is actually an essential fatty acid. So now this arachidonic acid is a precursor for the synthesis of eicosanoids. When you talk about eicosanoid, eicosa means 20 carbon atom or 20 carbon compound or 20 carbon molecule. That's what we mean by eicosane. When you look at the aliphatic nomenclature, we call it eicosane. So those class of fatty acids that have 20 number of carbon atoms that functions that have an hormone-like function are usually called eicosanoids. Example is the prostaglandins, the thromboxane, the leukotrienes. They function as they have hormone-like properties. Usually they act within the cell, which can be known as the autocrine, or they can act within the cell vicinity, which is termed a paracrine, which is different from the exocrine and endocrine in terms of when we look at hormone. So this is the fatty acid. We have the palmitic acid, we have the stearic acid, and we have the oleic acid. So the palmitic acid is a fatty acid that contains 16 carbon atoms. The carboxylic head, which you can see here, this is the carboxylic head. This is the carboxylic head. And then carbon there is actually the number 1 carbon. So this is number 1 carbon. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is palmitic acid. This is stearic acid, which is 18 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Stearic acid is 18 carbon atom. Oleic acid, which is a monounsaturated fatty acid, has a double bond at carbon 9, between 9 and 10. So we'll give it the lowest possible number, which is 9. So this is the first carbon, which is the carboxylic acid. Carbon 2, 3, 4, 5, 6, 7, 8, 9. So this bond is between 9 coming. Okay. So this bond is between 9. Let's say this is between 9 and 10. So give it the lowest possible number. So this is 9 carbon. The double bond is at the 9th carbon. So you can see the orientation of the double bond is in the cis form. Cis double bond. And this cis double bond makes them to bend, which is referred to as what? A kink. And this kink is actually important in the formation of membrane. It actually makes the membrane more fluidic. So this is linoleic acid, alpha-linolenic acid, and arachidonic acid. You can see here we have linoleic acid, which actually have 18 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. So there is a double bond at carbon 9 and at carbon 12. So 13, 14, 15, 16, 17, 18. So this is 18 carbon atom having a double bond at carbon 9 and carbon 12. So this is a polyunsaturated fatty acid. Alpha-linolenic acid is also a polyunsaturated fatty acid. Carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Carbon, I have a double bond at carbon 9, 10, 11, 12 at 12, and 13, 14, 15 at carbon 15. So this is a polyunsaturated fatty. The same goes for arachidonic acid. What you can see here, there's what we call omega-3 fatty acid, and omega-3 and omega-6. What do we define as omega-3 fatty acid? Omega carbon is the last carbon. This carbon here is the omega carbon. This carbon here is the omega carbon. So if you count from the omega carbon, we have omega 1, we have 1, 2, and 3. So there's a double bond at carbon 3. That is why it is referred to as omega-3 fatty acid. There's a double bond at 3, between 3 and 4 when you count from the omega carbon. That's why it's called omega-3 fatty acid. This is called omega-6, 1, 2, 3, 4, 5, 6. So there's a double bond at the 6th carbon when you're counting from the omega carbon. So this is a common fatty acid, the systemic name, the symbol, and their structure. So you can see here, this is dodecanoic acid, lauric acid, meristic, which is carbon 14, palmitic 16 to the rest. So you have here, this is how they are named, the structure. You can see the carboxylic head, this carboxylic head, which actually have carbon 1. So this actually the hydrophobic tail, which have 10 carbon here plus 1 here, that's 13, plus this one 14. Sorry, 1 plus 10, that's 11, plus 1, that is 12. That's why it's called 12 lauric acid. This is 1 plus 12, 13, plus 1, that's 14. That's why it's called meristic acid. As you go on, so you can see here, for the unsaturated, you can see here, this is 1 plus 7, that's 8 plus 1, 9. You can see that the double bond is between 9 and 10, then plus 5 here, which will give us 15, plus 1 here, that's 16, palmitic acid. So we have actually talked about the essential fatty acids, which are fatty acids that cannot be synthesized by mammals and are yet necessary for normal growth and life processes. These essential fatty acids are linoleic acid and alpha-linolenic acid. They must be obtained from in the diet because they are actually source. The linoleic acid is actually source for arachidonic acid synthesis, which is the principal fatty acid required in the synthesis of eicosanoids, which functions as, which have hormone-like properties. Example of those eicosanoids are the prostaglandins. We have the prostaglandin F2 alpha, which is responsible for the contraction and relaxation of the smooth muscle, the dry muscle. So that's what causes the menstrual cramp that ladies experience during their menses. It's the prostaglandin F2 alpha. So that is why they usually take some drugs, which is the NSAID, the non-steroidal anti-inflammatory drugs. So these drugs can actually inhibit the enzyme that is responsible for the synthesis of this prostaglandin, and those enzymes are COX, cyclooxygenases, or known as what? COX. They are called COX, cyclooxygenases of prostaglandin synthesis. Thank you very much. Do not forget to subscribe to my channel.